Hey everybody, I'm Doug and this is AstroAF. So over the past several months, I've been spending a lot of time working on harmonic AF, a little bit of information up here, and collecting data whenever clear skies allowed. Between development work, testing, and imaging sessions, the data kept piling up faster than I could process it. So today I finally have well, it's not rainy, it's cloudy. We should get some rain, but I have some free time in combination with that, and I wanted to take this opportunity to look closer at one of these projects. It's the Medusa Nebula. Now, this isn't going to be a traditional processing tutorial. I've always felt that processing videos can be difficult to follow because no two processing sessions are exactly alike. Even when working with the same data, the decisions made along the way often lead to different results. And then there's different screen resolutions and different colors and things like that on your monitors. There's a ton of different variables that can go into getting different results than what you saw in a tutorial. So rather than showing a sequence of buttons to click, I'd rather focus on understanding the data itself. So instead of a processing tutorial, we're going to decompose this image. I'm going to break the SHO composition apart into its sulfur, hydrogen, and oxygen components. We'll examine what each contributes to the final image and discuss how those observations influence the decisions that ultimately shape this final result. All right, so let's get started. I'm Doug, and this is AstroAF. All right, before I get into processing and jump down into the screen share, the Medusa Nebula is also known as Able 21 or Sharpless 2-274. It is a large and ancient planetary nebula that's located approximately 1,500 light years away in the constellation Gemini. It spans roughly 4 light years across. The nebula is a remnant of a dying star that expelled its outer layers into space about 10,000 years ago. Its braided and serpentine filaments of glowing gas resemble a snake-like hair of the mythological Gorgon Medusa, giving the nebula its familiar name. So planetary nebulae are fascinating objects because different emission lines reveal different physical structures and ionization states within the expanding shell. So for this project, I collected deep SHO data and was particularly interested in understanding how each channel contributed to the overall structure of the nebula. Let's go ahead and dive in and we can take a look at each one of these channels and discuss more in depth. All right, over here in PixInsight, I have my normal setup. Along the right-hand side here, I have all of my process icons for my setup. These will definitely vary by individual. And then to the left of those, I have all the work that I've done. And I wanted to start with this Decomposing Medusa video with kind of looking at the final image and then walking back through and just talking about some of the steps along the way and what I was looking at, what I was trying to do, and the type of techniques that I applied in order to get there. So looking at it from the very ending, this is an image that I actually processed in an application that I wrote, which is freely available. It's on my GitHub, it's open source, and it's called AstroAF Diffraction Spikes. And so what it allows you to do is to take an image, load it in, using the load image button over here, and then you can then run processing on it to apply diffraction spikes. And you have complete control over the spikes themselves, how many stars that you'd like spikes applied to. You can use these threshold sliders here in order to adjust that. And the length of the spikes and the thickness and their position and rotation on the stars. I also have some presets here which allow you to just choose some defaults that work pretty well. And it all depends on your image and what you have and your stars, but you might find that one of these defaults works well for you, or at least gives you a starting point. And then you can also adjust the blur kernel and the strength of the blur so you can help blend your spikes into your composition. And then just click process. So you'll see the result like what I have here. And then again, you can zoom in and it zooms both the original and the processed image, and you can drag around and have a look and compare at what you have. And when you get what you like, you might go through this a couple times and make adjustments and reprocess. Then you can go ahead and save your image, and you can save it off in different formats. And also you can load different formats. It's all shown and described in the documentation on GitHub. So if you want to have a look at that, the link for it's down in the description. All right, so that was my star spike applied image, and that was the only thing that I did to this. So on the final image, which is what we're seeing here, that does not have spikes applied, the only thing that I did in this was to do a little bit of enhancement. I'll back through it. First of all, I put my signature on here, and that was done through SETI's Astro script, the Astromark Signature and insert adder. Handy, and it's nice for being able to apply your signature to your astrophotography. But if I undo that, we're going to see Blur Exterminator here first. And what I was doing is I created a mask. And if we look at this, I think it might be, which one is it? It's this one here. So I created this mask with ACDNR and just created a lightness mask, set up the preview, and then enabled the preview, and then made these adjustments for this to create the mask that I was interested in creating for it. And then, as you can see, this is somewhat blurry here. So I took convolution and I applied convolution to this, which was probably about maybe 13 or 14 standard deviation. And you just got to do it to taste. You want to have have the edges be blurred enough that you don't have any hard edges, and then apply. You can definitely mess around with that and figure out what you like. For this particular image, that's about where I was at. Anyway, that gave me that blur. And what my intent here is to protect this area here, and then I applied Blur Exterminator to it because I was looking to enhance this particular area. Before you apply a mask, you create a clone from your original image, and then you apply your mask to that clone, and from this, I created the SHO mask clone. Yeah, so anyway, I just did a little bit of work there in sharpening because there's a really cool detail in here, and I wanted to make sure that was represented well. And then I also worked in curves transformation during this time. Really what I was working on for curves transformation in this step was enhancement of this background area and balancing the contrast between the darkness, this red dust, and the ionized hydrogen, and then also working on the central core area of the nebula, the oxygen, hydrogen, and sulfur that's in here, and working on balancing out these colors and getting as much detail. I also did work with the luminance channel and the C component and saturation. And saturation is usually I'm pulling saturation down, but if we go kind of look at that, we can play. So what I have here, I usually start out with RGBK. I'll go find the a really dark area and get an idea of where that is, and apply a stop. Now it depends on what I'm working on. So if I'm working on background here, I'm going to be concerned with the area down here lower, and then so what I might do is add a stop, and then work on what I want to do in the background. This does affect in the proper too, because you can see we as we lift up here, we get a change in our curve. So if you want to manage that, then you can pull down here and then control that by moving your center slider where you like, and now that's sort of locked in, and and then you can work on the background for your contrast as needed. And then I run through each one of the colors, and I'll kind of do the same with red. And I'll work on enhancing the image and trying to balance these colors, and then move on to green. My move on green is generally to lock the top and pull it down, and then to bump the bottom. And this brings in that, and this isn't what I want right off the bat, but what it does is it sets me up to add the blue, and then I can kind of lock that in, and then I can adjust the blue to mix with the green. And I just want to make sure I don't go magenta on it like that, you know, and then I can mix that and balance the blue and green and the red together, you know, in that way. And then generally I'll come over to luminance and I'll take a look at what we have for our brightness and work on detail. And maybe if it's a little too much on the top, I'll pull that down, and then I'll look at what that luminance does to our background. And I generally kind of like to keep this subdued. And then the C component, I like to kind of boost color in this way. And I find what I like. And that might be the only move on the center, and then come over to saturation, and then I'll usually pull that down some, and that just kind of softens a little bit of that color, keeps it from wanting to clip, and works on the balance. So that's kind of my approach to curves transformation. And in addition to that, in curves transformation, this is probably where I spend the majority of my time in processing, is to do this in multiple steps. So I don't try to do all this all at once. So you know, when I first come in, I'm really looking for the object, and to get a baseline on the background and the contrast, and to bring that out, and then apply that, come back in, reset curves transformation, and then start working basically from the same process again. I'll start with RGBK, get my base levels, and then I'll run through the colors RGB, run through luminance, and then C and S components. I don't do a whole lot with like the A component or B component very much. I mean, if I want to boost some yellows or something like that, or blues, the B component can be really useful. I don't know if you've ever messed with it, but if you push up, you'll get yellow, and if you pull down, you'll get blue. And it can be handy if you're looking to emphasize, you know, one or the other of those. And then you still have control over, you know, if that's going to be in the background. And it's a nice tool. And you might find that it allows you to get a color to the level that you want it selectively in your composition. So anyway, have a look at that tool if you haven't used it before. All right, so we'll get out of here. This was the state that this image is in when I came in and did my final curves transformation. Now, I did more curves transformations before I got here, but this was basically coming into my final image. So before I got here, I had reached this point in composing the image starless. And if we also, you know, look at stars just for context, let me do stars real quick. So I created this star image. This was created from the narrowband to RGB star combination. It's a nice tool. It allows you to control your color saturation, your amount of stretch. It allows you to remove green noise if you have it, and then to get your stars, you know, stretched to a point that you like. Now, my goal in this is to actually get a stretch that I want. I don't want to have to do, like, you know, if not necessary, blur exterminator and things like that to further modify stars. I'd like to get it right the first time. So when I'm in the script, I've got my star images here. So my HA stars and my O3 stars and my S2 stars. All right. And not always C, so I'm not doing anything with that. I'm going to go ahead and select the green channel blend, and we'll look at it. I do want to apply a star stretch to these, and we want to show the preview. So before I do anything, we're going to preview this. So we've got the stretch. So I like to take a look at what we have here. This default stretch was actually quite good and really close to what I was looking for. I do like what the color boost does, and so I like to push that up a little bit. And I think it brings out, the blue and everything. The green, I didn't see a whole lot of green, but I did bump this up just a little bit, as I recall. And, just for kind of final polish on this. And this was pretty close to where I ended up landing on my stars. If we kind of look, yeah. And so I executed that to create the image that's behind here. All right. And then what I like to do, and if you look at this image, it has been further processed because I like to, so I'll make a clone of this. All right. And this is my clone. And this actually ends up being my mask. And again, what I like to do here, and I created this with ACDNR, again, real handy tool for creating masks. And then I got this set up so that only the brightest stars that I wanted to be like in the foreground were protected. And then once I did that, I went back in and applied the same thing. I went to convolution and I applied a blur to all the small stars, and the ones that are, that would look like they're further away or smaller. And so I gave those a blur. And with the mask, that left the foreground stars without any blur applied to them, so that they were still sharp. But what that does is it gives a sense of depth in the star field. So we've got these foreground stars that are sharp and round, and we've got these background stars that give us a sense of depth because they seem further away, whether or not they are, because they've got a little bit of a blur applied to them. And as far as the human eye and brain is concerned, that basically gives a sense of depth to an image. And it's a great technique for giving depth, to your astrophotography images. And if you haven't tried it, I would give it a shot, because to me, this is it's a very simple way to go about adding some high definition to your astro images. So that's pretty much the stars. What I did from there is I just use a simple Pixelmath, and in this case it was just SHO plus stars, and then I output to whatever you want to name it and apply it, and that applies your stars to your image. Okay. And that's how I created that. I try to keep it simple. So here, this was my work all the way up to this point, and so we can sort of backtrack through this. So as I go back, so I did a blur exterminator here, and this was just as a final sharpening process on this image before I brought the stars in. Okay, and as you can see, we just softened up, and then I did work in curves transformation, and it's kind of, as we go through, you can kind of see there. Let me bring that back in of what I was working on. So if I redo the curves transformation, so as you can see, I was wanting to emphasize that that IFN and ionized gas that makes up the background of the image. I didn't do a whole lot with the nebula in that step. It did a little bit, but not too much. And then so that step was all about working on the image. So there were two steps there. So this step, when I come into it, I was working on the nebula. And this next step, when I come into it, I was working on the background. So as you can see, I like to divide that out. I like to focus into those areas and ensure, that I have a kind of a separation of concerns, if you will, and focus, not try to do everything at once. As I go back, I had even another step of curve transformation, and really I was just working on color of the nebula at this point, and a little bit of getting the background set up for the next iterations. When I start, I want to work on bringing in the background up to a level that is going to help me out, when I get to those steps where I'm focusing on the background. I did a histogram transformation prior to this, and if we undo that, so I'm working on basically brightening and getting the black point and our levels set at this point. And that was basically it. So that's where I started out with this version of the image. And what this is here is the combination of Pixelmath of my SHO images, which I'll show you next. So in order to get to this SHO image that we started with, I have a FORAX Pixelmath here, and I've actually talked about this before in another video, but I adjust these numbers, so 0.3 and 0.7 here for different weights for S2 and HA in the red channel. And then same thing with HA and O3 for green in the green channel. And then blue, I just run blue. Sometimes I will mess around with this and give it a multiplier, but in this case, I did not. And I will just output an image just where we started at with this other one. Okay, and so that's the image that we started with. So this was my SHO composition that was created from my individual mono masters. All right, and so that backed us up to the point where we were working on individual master frames before we got to this composition, at which point we started working on that. So yeah, so the Pixelmath, I'll go through this again so you can screen copy it or whatever. So my red, green, and blue, and this is FORAX Pixelmath. So if you want to apply, the FORAX processing to your images, which I really like for SHO, it's one of my favorites, and I use it often. Then you can certainly create a Pixelmath. You can use this Pixelmath, and I think it should work in serial as well without a problem. So. All right, and then my individuals. So really, the idea on these was to bring them from their linear state out of linear, get them balanced. What I liked about this is, like in my HA, as we had this great detail around the background. What I found really surprising was in the Sulfur, we had so much background here. I expected it to be more like the oxygen, but in this particular target and object, the amount of data and signal that I got in from S2 was much more than what I had expected. But yeah, so the process for this, we can just look at HA if you want. So yeah, histogram transformation. This is where I was basically just getting our level set. And all right, yeah, so I'm setting levels. And I do this multiple times as well. And we're basically getting back to, let's see, yeah, it's going to be all blown out, but just bear with me on that. This is not what it actually looked like. And this is an oddity I haven't quite figured out yet. But before this, I removed the stars to get my HA stars image. All right. And noise exterminator. And it's at this point where I think if I get rid of that, and reapply it. Okay, now it's back to normal. Okay, that's just really weird. And then I did a dynamic crop just to get everything lined up. I have that crop. Once I create a dynamic crop, I'll usually save it for the session so that if I need to come back through and reapply a crop or something, then I have that. I can open it and drag and drop it on stars or whatever that need to be cropped yet. And then continuing to go back through. So that dynamic crop, and I changed the image identifier here. All right, and this is basically where I think I brought it in. Okay, so if we go back and look, I would like to spend a minute just looking at histogram transformation. So if we come back in, that Pixelmath there was a background extraction. Then I applied noise X just to clean it up. I like to do some noise reduction before I remove stars. It usually helps the stars clean up nicely in the star exterminator, which it did. And then I started on the histogram transformation. All right. And so we'll remove I won't apply, but we'll just go in and have a look. So really what I'm looking to do here is to bring this image autolinear. Now you can use your STF as a starting point if you want. I generally do not. My goal is to be pulling this up and making sure I control the black point without clipping. And then, the stretch. Now I'm not going to apply this, but where I ended up getting to after that particular step was here. Okay, and I applied that, and then I did another step of histogram transformation on this, which I can come in and look at it at this point. Okay, so this is basically where I ended up with the last step. And then I'm going to apply more of a stretch. Control the black point. And I found in this particular image, probably right about in this neighborhood, keeping the black point under control and giving it the boost. Now I want to leave some headroom because I'm going to be further boosting signal in curves transformation, and so I want to leave myself room to do that. So, not necessarily go too far with the stretch. So if we look at where I landed on that, if I redo that histogram transformation, that's where I landed. So that was the entire processing for the hydrogen alpha, and it's exactly the same for each one of the other channels. So there's nothing new to show you in those as I went through that. And before that, that was where I brought these masters in after stacking. And I'll show you a little bit about weighted batch pre-processing here. I've got a short bit of video. It took 2.5 hours to get through the stack on my data here. I had quite a bit. I'll show you what I had actually, what data I had and how I worked with it. But anyway, that's basically the decomposition. So pretty simple. I don't try to make things too complex, and I'm just looking to work with my data and compose an image that I like in the end. And anyway, I hope that you like as well. If we look back at it, and again, if you like star spikes, this tool is available to you for spikes. And if you don't like diffraction spikes, well, then just using this type of process to get through, you can hopefully get to a result that you like, that makes you feel that you've got where you wanted to with your data. But anyway, that is decomposing the Medusa Nebula. My kind of takeaways on this data was that the oxygen channel really seemed to form the visual backbone of this nebula. And in looking at it, and the core, it is sort of like the background with the hydrogen alpha and sulfur on top of it. I think this is where most of the bright structure comes from in here, and these internal filaments and detail. I think those became apparent through the oxygen 3 layer, and so many of the features that are immediately attract the attention of the viewer of the final image, I think, originate here with the oxygen. The hydrogen alpha, I think that the HA channel revealed the broader and more extended view of this object, the surrounding region of the object. The outer shell, it becomes the outer shell becomes more apparent, and the surrounding emissions kind of emerge from this particular channel. But HA, it provides the context and scale, helping place the brighter structures within the larger environment, if you will. And with the HA in the background, and then trying to establish, kind of the HDR and depth, I think that that's really useful with the different brightnesses and different levels of focus on the stars and things like that that I was able to get through convolution. I think gives the image depth. And then the S2 channel, I thought it turned out to be one of the more interesting parts of this composition, and I really thought that S2 was just going to be filler and subdued, and instead the data revealed substantial structure in S2, especially in the region around the nebula. So that was really a surprise for me. And then rather than acting as another supporting filler, then I thought it contributed meaningful information here to this composition, and and the dimensionality of what I ended up with with this data. So anyway, that was one of the more surprising findings that I had. But yeah, so as those channels were recombined, provides the bright internal structure, and hydrogen provide the scale and environmental context. Sulfur contributed to the complexity and the background and shape and the fill and the detail of that IFN and ionized gases. So yeah, really the final image here is not a result of any one channel. It's this composition of all three channels, supporting their role in the final image. So anyway, I think that, this is a result of learning and understanding, through the data, and every image is different, what each channel has to contribute, and exploring it. And I did so much of just experimenting and going in and seeing, and I threw away a lot of work here that I didn't even show you in order to get here. That was just experiments that didn't pan out the way that I had hoped. And I think that's an important part of working through any composition. I don't think it ever goes perfectly, and and oftentimes you work into a dead end, and you need to backtrack and determine where things went south on you, and then make corrections from there. And so that happens all the time. It's natural. So the result of understanding what each channel contributes and how to apply that and bring those out in your processing decisions, to help preserve those contributions and then get something that makes you happy in the end. So anyway, that is Decomposing Medusa. Let's take a look at what I have for preparing the masters. I won't spend a ton of time on the stacking thing. I'll just show you my setup. All right, now I'm going to set up WBPP for the project. All right, so first off, I want to go ahead and just clear. And then we'll go ahead and load the directory. And so what I have, I'm going to come in here and look at Medusa. I've got all these in a grouping keyword, so I can just select Medusa here, and we should get all of my darks, flats, lights, and calibration all at one time. So calibration looks good. I do want to, let's get rid of that, and we'll add the keyword. So those are all grouped as we expect, and looking at post calibration. So I've got about 22 hours and 30 minutes accumulated data on here. So these all kind of evened out, and I'm heavy in the S2 on purpose. All right, so these are already normalized. So I'm going to begin, as I always do, with a background extraction on each one of these. And basically my go-to on that will be SETI Astro's automatic DBE. All right, those look like they cleaned up pretty good. So one of the reasons I wanted to create this decomposition rather than a traditional processing tutorial is because the most interesting part of the astrophotography isn't always the software. It's the data that you're able to obtain. So the goal isn't to memorize a sequence of processing steps. The goal is to understand what the data is showing you and make decisions accordingly. So sometimes an experiment succeeds, sometimes it fails. Both outcomes are useful. And so I hope this walkthrough provided some ideas you can apply to your own processing, and encourage you to spend a little more time examining individual components that make up your final images, and to think about not necessarily following by rote a process of button pushing and things like that, but look at what type of results you're actually getting from the steps. Now, obviously, there's an order to some things. You have to bring an image out of being linear before you can start working in the color space and things like that. As you get into your own processing, I encourage you to just experiment and be a mad scientist sometimes, and see what something will end up doing for you. If you have an idea, go for it. Spend a little more time examining the individual components that make up your final images. But hey, thanks for watching. If you enjoyed this video, please consider leaving your comment and letting me know what you think. If you'd like to continue the discussion, join me over on Discord. And if you'd like to support the channel, check out the memberships, merch, and other links in the description below. So I'm Doug, and this is AstroAF. Clear skies, everyone.